Biodegradation testing process for water-soluble materials in aqueous systems. Water-soluble materials are tested for biodegradation in aqueous systems using a unique test method that was developed from over 50 years of research. Let's start with our water-soluble material that's dissolved in water to form a solution at real-life levels of around 1 part per million. In real life, after the water-soluble material serves its purpose, it is expunged down the drain and ends up in a wastewater treatment facility. To test the end of life in this environment, the microbial community is pulled from this typical wastewater treatment plant into a test vessel, and the specimen material that is being tested is introduced into this test vessel. The microorganism concentration in this wastewater sludge, also called inoculum, is around 3,000 to 4,000 parts per million of microbes to water. In this environment, the microbes eat away the specimen material very rapidly. In fact, this biodegradation is too rapid for normal analytical instruments to measure it. Scientists felt that this is not enough to qualify a material as biodegradable, and they wanted to slow down the process so that it could be measured and definitely proven. They set about doing this by looking at two vectors, the test material concentration and the inoculum concentration. They started from the real-life conditions of 1 parts per million of test material in 3,000 to 4,000 ppm inoculum concentration as the baseline. First, they increased the specimen material concentration tenfold from 1 ppm to 10 to 20 ppm. Next, they diluted the inoculum from 3 to 4,000 ppm by 100 times to 30 ppm. These extreme conditions enabled the biodegradation process, i.e. oxygen uptake by the microorganisms when they eat the test material, to be analytically measured using standard equipment. These tests are thus conservative and stringent by design that provide very limited opportunity for biodegradation. The idea being that a material giving a favorable result in such a screening test should biodegrade very rapidly and effectively in any conditions that are better, the green area in the chart, i.e. real life. This is the basis for the screening tests used for determining biodegradation of materials in aquatic systems. These are designed to see the strictest possible conditions much worse than in real life. These tests by design used untrained microorganisms so as to ensure typical wastewater communities can quickly adapt to the test material, another level of difficulty baked into the test. The pass criteria of 60% in 28 days under these conditions is indicative, as seen over 50 years of data, of rapid biodegradation in mere hours in real life. However, this does not mean the material is going to remain for 28 days in the waste treatment plant. It is a screening test meant to slow down the process for enabling measurement, and the data needs to be treated as such. A test designed to be extremely strict so as to ensure that real-life conditions will completely biodegrade these materials. With over 50 years of data to support this hypothesis,